Hello everyone, let's take a look at our next problem. Show that the equation 3x plus 2 cosine x plus 5 equals 0 has exactly one real root. Okay, so I think maybe we just combination of sketching the graph and kind of just or looking at properties of things. So you know what my first instinct is here is taking a derivative of this thing and showing that it's never equal to 0. And in fact, if you just look at all three parts of this the thing on the left-hand side separately, it becomes pretty obvious that this thing can have only one real root. So let me write this down. Okay, so I'm going to think of the thing, it's an equation, it's not a function, right? But I'm going to think of the thing on the left-hand side as being a function of x. Okay, it's continuous. If I take limits to negative infinity and positive infinity, well, I can write out what this is pretty easily. Okay, so there is some value of x where this thing becomes negative. There is some value of x where this thing becomes positive. And so by the intermediate value theorem, there has to be at least one value of x where this thing becomes 0. Okay, but what we want to show now is that this is the only value of x where this equals 0. And the way I'm going to do that is by taking a derivative. Okay, so 3 minus 2 sine of x. This is never equal to 0 for any real value of x because sine of x is bounded between negative 1 and 1. In fact, I can write that 3 minus 2 sine of x is always greater than or equal to 1. And it'll be equal to 1 exactly when sine x is equal to 1. Okay, so it's a strictly increasing function, and so it can't possibly have a second real root. Yeah, there's not too much more to this other than just sort of, you know, when I first looked at this, I just thought about what this function might look like. The first thing that came to mind was I have the 3x part, which is unbounded, and then the cosine part, which is bounded. And so, you know, they can't possibly cancel each other out too much. I don't really know how to put my intuition there into better words. But once I saw that, you know, the limits to negative and positive infinity, you know, establish pretty easily that this thing certainly crosses the x-axis at some point. And then it's just a question of showing that it can't possibly ever turn around. There's not going to be a critical point or a horizontal tangent. Yeah, if I find a mistake or if I have more comments about this one, I'll put it in the description. Otherwise, thanks for watching.